Assalamu alaikum. So the lesson today is about rational functions. So we are going to give you an introduction to rational function or rational expression, so as you wish. So, but first let's give a definition of rational expression. So what is a rational expression? A rational expression, in fact, is just another way how to write division of two polynomial. That's all. So it's just a notation of uh, division of two polynomials. So rational expression is just another way to write uh, the division of two polynomials. So denoted by, so everyone knows the notation of a fraction, so it's the same thing. So we have px over qx, which mean in fact is the same thing as if I have p of x divided by q of x. This is just a notation. Given that px and qx are polynomial, so where px and qx are polynomial with any degree, but we have one condition, we know that every rational number cannot have 0 on the denominator. So the same thing here, because in fact what do we have? We have an expression over an expression. We know that expression is a number, or it's another form of a number. That means if an expression is on the denominator, that means this expression should not be equal to 0. So this is the condition, is qx cannot be 0 for any x, for any value of x. So that's the condition. Let me give you an example of rational expression. So for example, 5x plus 7 over 3x squared plus 9, uh, 2 over 5x plus 9 or plus 7, and I can have 7x squared plus or minus 3x minus 11 over 3x plus 12, and so on. So this is a rational expression. And sometimes let me give you another one, at least you will understand the idea. If I, for example, x squared plus 2x minus 1 over x, this is a rational expression. So this is another form of rational expression. So this is about an example of rational expression, and as we say that we cannot have a denominator of rational expression equal 0, so in that case we're gonna find out which value of x make the denominator equal 0. So on those value of x are called excluded value, because they are excluded from the value that make the expression undefined. So this is why we call them the excluded, because we exclude them from the value of real number, because those value make the expression undefined. So we're going to talk about excluded value of rational expression. So like I say, excluded value of rational expression are numbers that make the denominator equal 0. So this is the exact definition of excluded value. So excluded value of a rational expression, for example, px over qx are so valued as maybe one, maybe more. So our value of x that make the denominator our case qx equal 0. So let me give you an example. You can see the idea. But keep in mind, not all the rational expression can have excluded value. Some of them they don't have, and I will show you an example here. So example. All right. So if they ask me to find the excluded value of the given function, of the given rational expression. For example, over x squared plus 5. So x squared plus minus 5 minus 5, what's it? We got x squared equal minus 5. Square negative. So in that case, we have no excluded value here. So there is no excluded value. I mean, all the x, we work for this expression. So if I put any x value here, it was the whole number. So here, for example number 2, suppose I have 4x over 3x minus 7. So again, to find out the excluded value, I need to make the denominator. So I make 3x equals 7. So this is cancelled out. So divide by 3. So x equals, so here I will write here 7. So the excluded value is for a third x equal 8x squared plus 5x squared plus 5x 0. I factor any method, so x plus 2 times one of them is 0, so I make x2 equals 0 or x plus 3 equals 0. So here when I solve for 2, for here for x, I get x2 absolute value are minus 2 and minus 3. So I just and minus 3 are my excluded value. simplify an simplify rational expressions. So in order for us to simplify a rational expression, what we need to do, we need to factor the numerator and the denominator. And after that, what we do, we cancel the common factor. The same thing we do with numbers. So for example, let me give you this in numbers. So suppose we have 35 over, for example, 40. You see, here what I do, I'm going to factor the numerator. So it's going to be 7 times 5. Here is 8 times 5. You see, 5 is the common factor. So I cancel. So the simplest form is 7 over 8. The same concept. The only difference here, we are dealing with the expression, so we're going to use one of the method of factoring, either direct factoring, AC method, by grouping, or Alice method, or any method of factoring. You need to factor the both expression and cancel the common factor. So that's the idea behind. So in order to simplify rational expressions, so to simplify any rational expression. But keep in mind, sometimes we cannot simplify. Why? Because they don't have a common factor. You see? So in that case, there's nothing. Does mean this, the form you have is the simplest form. But sometimes you can. To simplify any rational expression, px over qx, what we to do is we need to factor the both binomial and simplify or cancel the common factor. So we need to factor both expression. I mean, or both polynomial. I mean the need to factor both polynomial. So at least will be more specific. Both polynomial. I mean the numerator and denominator. Then after that we cancel the common factor. Then cancel the common factor if there is any, because sometimes we can find any. The common factor if there are any, because sometimes we can have more than one. Alright, let me show you an example. It's better. So suppose I want to simplify this expression. X 13 x plus 5. So here what I do, I need to find x. Here we can use the what you call it, the AC method. So 6 by 5, so it's going to be x squared plus 13x plus 30. So we'll have 10. So here I multiply here by 3. So here will be 2x plus 1. times 3x. Now we see will be 2x plus 1, and this is the simplest form of that expression. Let me give you another exemplify this. For example, 4x plus 24x plus 2x squared minus 32. Again, here I'm going to take a common factor. So, but here we have a number as common factor, which is 4. 4 times x squared plus 6x plus 8 over, here we have 2 as common factor, which is going to be x squared minus 16. So now I factored this using direct factoring. So 4 times x plus 2 times x plus 4. And here we have 2 times x minus 4 times x plus 4. So as you see here, we have x plus 4 as a common factor. Here we have 2 as a common factor. So my final answer should be 2 times x plus 2 over x minus 4. So I distribute, I got 2x plus 4 over x minus 4. And please don't do this mistake. Don't try to cancel 4 and 4, then cancel x with x, then you do it, then write down equal to, because some students do that. So please, you cancel only if you have multiplication. With addition subtraction, we cannot do that. We cannot cancel the terms of addition subtraction one by one. All right. So let me give you another example. Suppose I want to simplify this expression. So 2x squared minus 5x plus 3 over x squared minus 10x plus 12, for example. Okay, let's make it 21, not 12. That's guess I will get my. All right. So here, when I factor this, I will have so it's, if I do a same method here, I will have x squared minus 5x plus x, which is going to be x minus 2 times x minus 3. So divided by 2. So here will be 2x minus 3 times x minus 1. And here, when I factor the denominator, I will have x minus 3 times x minus 7. As you see, there is nothing I can simplify. They have no common factor. So this is the simplest form. So I cannot do anything here. You see, sometimes we can, sometimes we cannot. All right, so now let's talk about the last thing I want to talk about it today is the domain of rational expression. So most of you have an idea what is the domain. So the domain is a set of all x that make the function has a value. So it's exactly what is the domain. So the domain is a set of all number that have an output. So the domain of a rational expression is the same thing, but the only difference here, we're going to be more specific. Why? Because we have a fraction, and we know that the domain of a rational expression are all the number that are distinct from the absolute value. Every number which is distinct from the absolute value is part of the domain. So this is exactly the difference between the definition of the regular domain, the domain of a function, and the domain of rational expression. We just go more specific. So the domain of a rational expression is the set of all number or real number distinct from excluded value. This is why we talk about excluded value first. So distinct from excluded value. So I will take all number except the excluded value. So this is another way so of that rational expression. So in order for me to find out the domain, I just look for the excluded value. So it's exactly how we do that. So example. So I want to find out the domain of this function. Find the domain of the given function. So x equals square minus 2x minus 3. So the first thing I need to find out. So what they do, they factor, they simplify. So what they do, they factor this, so they got x squared. Then they cancel, they end up having x minus 2 over x plus 1. And after that is so that's the only value is not part of the domain is minus 1. Everything is part of the domain. A little bit. We cannot expression unless if they are different than 0. Suppose I choose x. So simplify, then find no. We need to find a domain from the original. Here I make the denominator equal 0. So the square minus equal 0. So I got x minus 3 times x of x 0, or so when we saw we got x equal 3 or x equal minus 1. Line. So I pick everything except those two, minus 1 and 3. So all are the domain. Minus 1, 3, union 3, infinite. So this is find it. Let me give you another example. Suppose I want to find out the domain of this function. G of x equal x plus over x squared plus 7. Again, what I do, I make the denominator equal 0. So when I minus 7 both sides, I get x squared equal minus 7. So this is impossible. What does it mean? Does mean the denominator can never be equal 0. Never. Any value of x you pick never can be equal 0. Never. So that means all x will work for me. Every x here work for me. So my domain will be what? All real number. So the domain is going to be from minus infinity to infinite. There is no excluded value here. So if you have no excluded value, that means the domain is already number. Another one, so suppose I have hx equal x minus 7 over square root of x plus 4. We know that the inside of the square root must be positive. So this is an extra information beside different than 0. It's different than 0 and the inside must be positive. So here I'm not going to solve an equations, I'm going to solve an equality. So x plus 4 strictly greater than 0. So minus 4 both sides, x is greater than 4. So in that case, my domain will be what? I exclude the 4 and anything greater than 4. So it will be 4 to infinite. So this is about this introduction today. So I hope you understand the idea and you understand what is exclusive value, the relationship between exclusive value and the domain, and you know how to simplify now a rational expression. So I hope everything was clear. Thank you for watching the video, and please, if you have any comment that will help me improve my way of teaching, do so. It will help me a lot. Thank you for watching the video, and Assalamu alaikum.